Okay, let's talk about some polynomial function characteristics. Hopefully, as a class, you were able to come up with a couple of these on your own without me having to spell them out for you, but if not, we're going to go ahead and go over them right now. So the first one, now feel free as we go through this, if I'm going too quickly and you're not able to copy down stuff, to pause the video, hit play, and then catch back up with me. The degree, which is the largest exponent in the function, indicates the end behavior. So, if you have an even degree, your end behavior is going to go in the same direction. So, for instance, if my degree was 2, 4, 6, 8, 10, my end behavior is going to go in the same direction. Now that's a quadratic, so my degree is 2, but we could have something like a degree of a 4th degree, or a 6th degree. But regardless, notice that both of the arrows are always pointing in the same direction. Now if I have an odd degree, so the first one would be linear, so a degree of 1, a cubic, degree of 3, a fifth root, which, let's see if I can do this. Looks like that. Okay. Your end behavior is going to go in opposite directions. So notice one is always pointing to positive infinity, while the other is pointing to negative infinity. Alright, the second thing that I hope that you were able to figure out was that you will always have one less turning point than your degree. So, what do I mean by that? Well, let's look at a quadratic function. My degree is 2, but I only have one turning point. Let's look at a cubic function. My degree is 3, but I have 2 turning points. Let's look at a fourth root function. My degree is 4, but I have 3 turning points. So you should be able to look at any graph and tell me what the degree is by looking at the number of turning points and adding 1. Alright, this one is a lot, some of you probably caught on, but there's more to it than what meets the eye, I guess you could say. Alright, so your degree tells you your number of solutions. Now we have to be careful because we've opened up this whole new world of real solutions or imaginary solutions. And so we have to consider that sometimes there's going to be real solutions and sometimes there's going to be imaginary solutions. So how do I recognize them? How do I see them? Well, a real solution is going to be when the graph actually touches the x-axis. So let's look at some examples. I'm going to go back. If you need to pause it, and copy this down. Okay. Alright, let's look at some real solutions. So if I look at a quadratic function, okay, my degree is 2. How many real solutions do I have? I have 2 real solutions. Let's look at a cubic function. How many times does it touch our x-axis? 3. I have 3 real solutions. Okay, let's look at a crazy one. Let's look at a sixth root. So as I draw this, I should be able to use my mind that I'm not going to use my calculator, but I know that a sixth root is going to have my end behaviors going in the same direction. I should have 5 turning points. And if I'm going to do real solutions, it should touch the x-axis 6 times. So okay, look at my turning points. 1, 2, 3, 4, 5. It's a sixth root. Okay, and behaviors are going in the same direction. How many times does it touch your x-axis? 6. So I have 6 real solutions. Okay, but we can have imaginary solutions. And an imaginary solution is not going to touch the x-axis. So how do we find them? Well, you find them by looking at your degree, whatever it is, and you subtract the number of real solutions. And I'll show you an example in just a second. Something that you should always know to kind of catch yourself if you're making a mistake. Imaginary solutions always come in pairs, and we know that from the quadratic formula. You always have a something plus and something minus. So you should never ever tell me you only have one imaginary solution or 3 imaginary solutions. It's either going to be 0, 2, 4, 6, 8, 10, and so on, but it's always going to come in a pair. So let's look at this. Alright, I'm going to draw a function that is in the 5th degree, which means my end behaviors are going to go in opposite directions, and I should have 4 turning points. Oh, I think I made a mistake. 1, 2, 3, here we go, 4. Okay, my end behaviors are in opposite directions. I have 1, 2, 3, 4 turning points, so it is a 5th degree. Let's explore the number of real solutions and the number of imaginary. So I know that I have 5 solutions. How many real solutions do I have? How many times does this graph touch my x-axis? I have 3 real solutions. That means that I am going to have, let's see if I can make this a little bit bigger. That means that I'm going to have 2 imaginary. Okay, do you see how that worked? I knew I had to have 5 solutions because my degree is 5. It touches your x-axis 3 times, so that means I have 3 real solutions. 5 minus 3 is 2, so that means I have 2 imaginary solutions. So, of those 5 solutions, 3 of them are real and 2 of them are imaginary. Let's look at another one. I'm just going to draw a crazy function, a random function. Okay, well, tell me, what do you know about this graph? Okay, well, we know our end behaviors are going in the same direction, so my degree is going to be even or odd? Even. Very good. How can I figure out what is my degree? Well, let's count my turning points. 1, 2, 3, 4, 5. I have 5 turning points, which means I have 6 solutions. It also means my function is to the 6th power. Okay, let's explore those solutions. How many times does it touch the x-axis? 1, 2, 3, 4. That means I have 4 real solutions, which means I would have how many imaginary? Well, 6 minus 4. Again, I have 2 imaginary. Okay, one more thing. Distinct real solutions. This occurs when you have a multiplicity of 2. Go ahead, write that down. Distinct real solutions, pause it. Let me show you what I mean. Okay. What is my degree of this function? Well, let's look. I have 1, 2, 3 turning points, so it's to the 4th degree. Okay? Are you with me so far? Alright. How many times does this graph touch the x-axis? 1, 2, 3 times, correct? Okay. Well, from what we just talked about, that means if my degree is 4, that means I have 4 solutions. I subtract my 3 real, and that leaves me with 1. Well, we said that it can't be an imaginary because imaginary have to come in pairs of 2. So I don't have 3 real and 1 imaginary. This is where it becomes unique. The problem is that this is a multiplicity of 2 because the turning point touches the x-axis. So the multiplicity of 2 means it really has 2 solutions. Just like when the turning point was at the x-axis, I had 2 factors. I have 2 solutions. But you don't want to write them out twice. So let me kind of back up here. That means I have 1 real solution, 2 real solutions. This dot right here counts as 2 because it has a multiplicity. So I do have 4 solutions. But we don't want to say that solution twice. So the way we word this is we would say we have 3 distinct real solutions. Okay? We have 3 distinct real solutions because it touches our x-axis 3 times. We know there is a total of 4 solutions, but 2 of them are the exact same number. For example, let's say this graph crossed at, the solution was at x equals -4. This was at x equals -2. And this was at x equals 1. We wouldn't want to say that my solution is -4, -2, 1, and 1, right? Because we don't repeat that. I do have 4 solutions, but 3 of them are distinct, 3 distinct real solutions. Okay, let's look at another example. Okay, you might want to pause it and copy it down. Let's brainstorm. What do we know about this graph? We know that our end behaviors are going in the same direction. Okay, so we know it's going to be an even. We know that I have 1, 2, 3, 4, 5 turning points. That means it's going to be in the form of y equals x to the 6th. Okay, this is where it gets tricky. So that means I have 6 solutions. let's be more specific about those solutions. How many of them are real? 1, 2, 3, 4, right? I have 4 real, but we would say 3 distinct real because it actually only touches our x-axis 3 times. So that means I have how many imaginary? 2 imaginary. So if this was a test question and they asked you to describe the solutions, you would say you have 3 distinct real solutions and 2 imaginary solutions. All right, let's try one more. Okay, copy it down. Tell me everything that you can about this graph. Hit pause. Okay, I know it's going to have an odd degree because my end behaviors are going in opposite directions. I have 1, 2, 3, 4 turning points, so I know it's to the 5th degree, which means I have 5 solutions. It touches the x-axis 2 times, but one of them has a multiplicity of 2. So I technically have 3 real solutions, which means that I have 2 imaginary. But of those 3 real solutions, I know that only 2 of them are distinct. And that's what you would say. Of the solutions, you would say I have, of those 5 solutions, 2 are imaginary, and I have 2 distinct real solutions, because we know that this one right here counts for, has a multiplicity of 2, so it counts for 2 real solutions.